Wow, it's kind of low. If we could go ahead and get started. Okay. We got this? Okay. So we're going to go ahead and get started. I'd like to welcome everybody to the Writing Security Considerations tutorial. I am Karen O'Donoghue from the Edu team, and we provide the tutorials, the newcomers overview, and a number of the other things related to general training in the IETF. If you have any suggestions or comments about things that you think we need to do, there is a mailing list, edu-team, Edu team. And we would welcome any suggestions that you have. Also, at the end of this, there's going to be a link to a survey. We do actually look at the survey results, and so I'd really appreciate any feedback you have there. And if you have any suggestions for future tutorials, you can also put those in there as well. With that, I'm going to introduce our two speakers for today, Yoav and Linda, and good luck with your tutorial.
Hi. Okay, my name is Yoav Nir. This is Linda. We're both on SecDir, which is the body that reviews all drafts intended for publication for security issues. And one of the big things that we do is we review the security considerations section in every draft. And we often see a lot of things we don't like there. So we've come up with this tutorial to hopefully make the things a little better. Okay, so motivation. Why do we even write security consideration sections? So the first thing is that security is relevant to all protocols, not just those that come out of the security area. And it's obvious why we need protocols like IP, TCP, and the stuff that comes out of the security area, like TLS or IKE or PSEC, to be secure, because they're used by everyone. They include the cryptography, so they're important stuff. But other protocols also need to be secure. You can have the best security with TLS, and still, if you layer HTTP on top of that, HTTP can still give up all the security, the TLS notwithstanding. So TLS will not solve all your problems. Specifically, it's not going to solve the issues of credentials. So there's a lot of stuff about implementation and deployment issues that are not covered well in many documents that we get. Well, as always, feel free to run to the mic and ask questions if you want. Don't have to wait till to the end. So the security of a system depends not just on using good crypto, which TLS and IPsec will provide you, but also dispensing identities and credentials and verifying them. So suppose you have the protocol and you decided to use certificates to authenticate all the nodes within the system. Great. But who issues the certificates? How does the CA that is going to sign the certificate verify that whoever asked for the certificate, whoever sent the certificate signing request, is actually who they claim to be? How are the private keys secured? Now, this part is not really usually IETF domain, but it's also important for the system. And when one node connects to another, how does the other node first validate the certificate? And then how does it validate that the name in the certificate? How does that map to authorization? And more motivation. Well, SecDir review is part of the document publication process. Whether you like it or not, you're going to get a SecDir review. So, and the security area directors always read the SecDir review. And if you don't respond to the SecDir review, if you just ignore it, well, you're going to get blocks or discusses. So don't ignore the SecDir reviews. SecDir reviewers will read your entire document. Usually, there have been 600-page documents that we haven't really read every page of, but we definitely do read the security consideration section. So please make it the way it should be. So it's not just a good idea, it's the law. And by the law, I mean it's enshrined in an RFC. So RFC 2223, still valid, still not obsoleted, has section 9, that's it in its entirety. All RFCs must contain a section near the end of the document that discusses the security considerations of the protocol or procedures that are the main topic of the RFC. So you have to have it. A piece of advice is write them early. Don't leave writing them to the end of the process, because sometimes when you write the security consideration section, you say, oh my, oh, this is true. Well, we have to go back and revise. And you don't want to do that when you've already decided that the document is ready and you're ready to send it to the ISG. You just have to write this, these sections that are missing, the IANA considerations and the security considerations. No, don't do it that late. Another thing, if you think that there are going to be some contentious issues, ask for a sector review early. It's a few clicks on the website, on the data tracker. Especially if you're a working group chair, please ask for an early review. They can help. Okay, how do we get here? A bit of history. So once upon a time, you always hear that, oh, at the beginning of the internet, they didn't consider security. And it's sort of correct, or at least they assume that the security is either there or not needed. And a lot of RFCs did not have security considerations at all in them. And a lot of people didn't think about security when designing protocols. So RFC 2223, which we mentioned earlier, required security consideration checks, and this goes back to 1997. So then people didn't really know what to write, and they made some really wrong things in there. So in 2003, we had RFC 3552. That's just guidance on writing security consideration sections, and this is quite a big RFC. It's a little outdated here, but by now, but it's still mostly relevant, not entirely. And we tried to update it a few years ago, and unfortunately, we failed. We couldn't get the mass of people to review and comment and offer text, so that effort just died, unfortunately. So at the moment, this is what you have. And the Internet Threat Model is taken from RFC 3552, and you are encouraged to read that document. Okay, so the Internet Threat Model, as described in RFC 3552, includes that it's about connections going all over the Internet, and they assume that the attacker may be in any place on the path. So the attacker can modify any packet, drop any packet, spoof any packet. So never assume that the path is secure. If you want security, you have to do it between the 2 points. And you should also consider things that have evolved since then, the difference between off-path and on-path attackers. It's described in RFC 7430. And also consider that a sufficiently powerful off-path attacker can become on-path by pretty much convincing the internet to get your packets to go through something controlled by the attacker. And there's lots of ways of doing that. Also consider privacy considerations, which became more important in recent years. See RFC 6973 about that. And pervasive monitoring that we've started worrying about relatively late. That's in RFC 7258. And trust. Trust is an important thing to consider, because one of the best ways of getting an angry comment on a sector review is saying, node A is trusted. What do you mean trusted? Who trusts it? Trusts it to do what? So it's always A trusts B to do C. Never just B is trusted. It's never good enough. Even CAs. CAs are not trusted. They're trusted by specific people to do specific things. I mean, if you look at even at the web PKI, and that's a lot of CAs there. There's the famously there's the South African Post Office. When did I ever trust this South African Post Office? I never did. Well, Apple and Google and Microsoft decided for me that these are trusted things. So I'm really trusting Microsoft and Apple and Google to decide well who is trusted. Okay, well, trusted at least for browsing the web. Okay, so questions you should ask, and all this is material from 3552. How much do you need confidentiality? Do you need data integrity? Do you need peer entity authentication? Usually do, otherwise you're just sending stuff to anyone on the internet. So are the messages really expected from peers rather from attackers? And are the messages really sent from the expected peers and not to attackers? Right. The security consideration section needs to explain which attacks are in scope and which are out of scope, and why are they out of scope. And the attacks that are in scope and are those that the protocol is susceptible to and that the protocol protects against. Okay, attacks that you need to consider. There's targets, even in walled-in systems in your data center, such as router and switches that are in cages or, well, in your data center, behind the firewall, are susceptible to internet threats because usually can get traffic from the internet to those nodes. And especially that they have ports that are facing external, more vulnerable targets. You should think of passive attacks like sniffing and other cryptographic attacks. And there are common issues that of shared keys. There's kind of a design pattern or an anti-pattern that you have a group of hosts that all have the same key. Certificates are often mismanaged, downgrade attacks, denial of service attacks, firewalls. All this and much more in RFC 3552. Please read it. Okay. Attacks to be considered, active attacks. Active attacks are obviously require more resources, but we have quite a few people who can do, quite a few entities who can do active attacks. There's spoofing attacks, replay attacks, message insertions, and man-in-the-middle attacks. Okay. So, what has to go into the security consideration section? And the first thing is that everything that goes into the security considerations section has to be about this new stuff that you that is in your document. If your document is running over IP, you don't have to cover everything that goes into IP. If your protocol runs over TCP, then you don't have to cover that either, unless you're in the transport layer, and then you make changes to TCP, and then yeah, it makes sense to write what has changed in TCP. But if all I'm doing is sending some, I don't know, content over JSON, I don't have to describe JSON, I don't have to describe HTTPS, I don't have to describe IP. All that is in other documents. I don't even have to reference them, just what is new. And there's always something new, otherwise you wouldn't be writing a draft, right, would you? So, anything about the threat environment should go in the security considerations section. TCP client that is anywhere on the internet, maybe behind NAT, maybe not, and is connecting to a server that is in the cloud or in some data center. That's the internet threat model. You don't have to describe it all over again because that's been described many times already. So if your environment is different, yeah, please go and describe it. Example, yeah. This protocol variation inherits all the security properties of regular ESP, that's the kind of IPsec, encapsulated security protocol, as described in RFC 4303. Okay, this line is taken from a draft that didn't make it to RFC in the end, not because of security considerations. It's from draft SHU TikTok security for synchronization. It's about protecting IEEE 1588. Now, in case you don't know, IEEE 1588, also known as the precise time protocol, requires consistent latency down to sub-microsecond or sub-nanosecond jitter. So when I first heard that, I said, well, any router is going to give you more jitter than that. And it told me, well, yeah, but our protocol doesn't go through routers. It only goes through special switches that have constant latency. I said, okay, nowhere in the document does it say that. And this is not the internet. If you don't go through a router, you're not running on the internet. So if your environment is this different, yeah, you should say that in the security considerations. Everything related to a router is not relevant here because we don't use routers. Okay, in scope and out of scope threats. It's fine for a document to leave some security aspects out of scope. but you have to say this. So, example, protecting the endpoint against flooding attacks is out of scope for this document because we're running over TCP, right? And TCP is already covered elsewhere. It should be mitigated with normal network management procedures. Now, usually if you're running over TCP, you don't even have to say that because that's true for any TCP. So when do we have to say this? Well, as an example, the IKE, the Internet Key Exchange Protocol, runs over UDP. So a few years ago, somebody made a document for IKE over TCP. That makes, so IKE over UDP has its own anti-flooding thing, its own anti-denial of service RFC. All that goes out the window once you run over TCP because then everything changes. So if I'm making an IKE over TCP document, yes, I should call out that everything we usually do with UDP out the window, this should be handled like any other TCP service. So if we change this for IKE, yeah, then we should call it out. Otherwise, no, if you're just making something over TCP. Okay, security, anything that has to do with authentication goes in the security considerations. So how is the authentication protected? And yeah, we use TLS is a good answer. How are credentials generated? How are the credentials dispersed to the nodes? How are credentials and verifiers protected? And this is hardly ever obvious. I mean, you think of authentication works well in the web. Well, authentication on the web is one way. It's only the servers that authenticate. The clients usually don't. And it's such a hard problem that there's a whole different standards organization called the CA Browser Forum that just has the browsers and the CAs, well, yeah, the name kind of suggests that, meeting several times a year, sometimes virtually, sometimes physically, to discuss how not to issue certificates to the wrong people. And it's a hard problem. They still have to meet often. So what I'm saying is that authentication is a hard problem, and if you're saying, okay, use certificates or we'll use passwords, you should elaborate because it's really hard to deploy. Residual risk. If there's still some risk after you've mitigated it with several mechanisms, call this out. A good example from RFC 5246, that's TLS 1.2. This, well, there's a paragraph before that that describes how they mitigate some timing risk, but this leaves a small timing channel since MAC performance depends to some extent on the size of the data fragment, but it is not believed to be large enough to be exploitable because the large block size for existing MACs and the small size of the timing signal. That's excellent text for the security considerations. Too bad it's not in the security consideration section, but at least they got it in there. Okay, risks from foreseen and misapplication or misdeployment. I mean, read your draft, and if you think, okay, people are going to implement this or deploy this in an insecure manner, tell them. Don't wait until they do some bad stuff. A good example from this document, the Shakes document. This is a document that describes how to use the SHA-3 hash functions, often called Shakes, with PKI. So this is an excellent document that provides us both with a good example, this one, and a bad example that we'll see later. So when using ECDSA with Shakes, the ECDSA curve order should be chosen in line with the Shake output length. NIST has defined the appropriate use of the hash functions in SP 800-78.4 or SP 800-107. These documents can be used as guides to choose the appropriate key size. In this case, we recommend that you use ID ECDSA with Shake 128 with a curve of order 256 bits, and ID ECDSA with Shake 256. These are both algorithms that are defined in the document, is recommended for curves with groups order 384 bits or more. Now, these curves are never mentioned in the rest of the document. They don't say which curves to use. But this is good advice for implementers so they don't mix high security shake with a low security curve. So this is good stuff. This is good advice, and this really should go in the security considerations section. So great for them. Now, if you can anticipate people doing something bad, tell them. Don't let them fail. I mean, it's not enough to say this in the working group, because the people who are going to implement this are not necessarily in the working group. So somebody gets an RFC and they tell them, implement this. They're not privy to all the discussion that went on in the mailing list and in the room. Okay, and what's important, this is very important for extensions, call out information that is sent out. One time I got this document to review that they had an extension for a protocol that included a message with the IP address of the server. This extension sent, in addition to the IP address, the name of the person managing, his email address, and his phone number. Sending that over the internet is not the same as sending an IP address. I mean, it could be okay, because they'll usually use not their home email address and not their home phone number, hopefully, but some help desk phone number. And so it might be fine to do this, but call it out. You're not, just because the previous protocol was considered good enough, doesn't mean that the new information is also good enough to send over the internet. So if your extension is sending information that was not in the base protocol, call this out and say that it's okay. It might be okay. I'm not saying that sending any new information is bad. Just call it out. And we'll see a good example in the pitfalls. So what does not go in the security considerations? Obviously, my chocolate chip cookies recipe doesn't go in there. So we could have a lot of slides here. But what we have here is slides about things that we often see in the security considerations section that shouldn't be there. And the most common one is RFC 2119 language. Now, I'm not making a blanket rule that never put a must in the security considerations, but usually it's wrong. I mean, if something is necessary to make a compliant implementation of your protocol, it goes in other places in the document. So here's the wrong thing is the Unix string value mentioned in section 4 must be 256 bits, high quality random bits, and the RSA key in section 4.1 must be at least 3072 bits in length and must be chosen using one of the approved methods in SP 800-56B. Okay, so what's wrong with that? I mean, to make a compliant implementation, I need to use 3072-bit RSA keys, and I need to use 256-bit Unix strings. This is not optional. This is not something I should consider. So the right thing is to put those requirements in section 4 and 4.1, and then in the security considerations section, well, say, okay, the requirement in section 4 is because we're trying to avoid birthday attacks, and the requirements in section 4.1 is the current state-of-the-art, assuming an attacker is not equipped with a large-scale quantum computer. If he is, then we don't really have a asymmetric algorithm at this point, so yeah, we're screwed anyway. So RFC 2119 language usually does not go in the security considerations section. Motivation, we see that a lot. Remember that IEEE 1588 draft? So here's the rest of the security considerations. This document describes modifications or extensions for the WESP protocol, that's wrapped ESP, for the additional application. The approach described requires the ESP endpoints to be modified to support the new protocol. It allows ESP receiver or intermediate node not only to distinguish encrypted and unencrypted traffic, but to also identify whether the encrypted packets are the common packets or the time packets by a simpler implementation for the transport node. Okay, this is motivation, and motivation goes in the introduction, doesn't go in the security considerations. I mean, we care a lot why you wrote this document, but this is not part of the security considerations. And random using, remember the shakes thing? Okay, here's the bad part. The shakes are deterministic functions, like any other deterministic function, executing multiple times with the same input will produce the same output. Therefore, users should not expect unrelated outputs with the same or different output lengths from running a shaken function with the same input multiple times. Okay, everybody knows that. I mean, if you're at the level that you're reading RFCs, I should hope you know what a deterministic function is. And at any rate, we have people coming, writing a document and, oh, we have to write this security considerations section, and I have no idea what I need to write, so random musings. No, this paragraph was deleted in its entirety. We don't need it. Okay, pitfalls. Learn from the mistakes of others. So the thing we see a lot is security considerations by reference. I mean, this is the people who say, well, others have already covered everything important here, so we don't need to. And you see this. The mapping extension described in this document do not provide any security services beyond those described by EPP, RFC 5730, the EPP domain name mapping in 5731, and protocol layers used by EPP. The security considerations described in these other specifications apply to this specification as well. Okay, EPP is a extensible provisioning protocol, obviously extensible because here we are extending it. And the extension is about sending financial information. I mean, this customer has already paid so many dollars, and we've already provided so much service, so their balance is so many dollars. And this was not in the base protocol in 5731, and it's in the extension. So something has definitely changed. I mean, the base protocol did not have financial information. The extension does. So you can't just say everything is already covered by the previous specifications. So yeah, please say, I mean, it could be okay. It could be okay to send the balance over this protocol because it is protected and it is going only to the customer. So telling the customer their own balance is fine, I guess. But you should call it out. This is new information that it was not in the base protocol. It could be sensitive in certain situations. So you should say that it's fine to send it because of all those reasons, but say it. Another thing, don't do more than one level of indirection. If I see, well, the considerations for this are the same as in RFC that, and I go to RFC A and the security considerations there just say, go to this older RFC. And at some point, this is too much. So if you have more than one level of indirection, either reference the original document or just write your considerations by yourself. Even if you copy and paste much of it, it at least makes you consider everything. Okay, another example. Procedures, protocols, extensions defined in this document do not affect the BGP security model. See the security considerations section of RFC 4271, that's BGP, and a discussion of BGP security in 4272 and 6952 for analysis of security issues for BGP. Great, so we're talking about an extension to BGP that sends TE, that's traffic engineering information, over BGP. But this is not all that there is in the section. The other paragraph says, the TLVs introduced in this document are used to propagate IGP-defined information, same as in RFC 7810 and 7471. These TLB represent the state and resource availability of the IGP link. The IGP instances originating these TLVs are assumed to have all the required security and authentication mechanisms as described in those two documents in order to prevent any security issue when propagating TLVs into BGP-LS. Okay. 7810 and 7471 describe sending the same traffic engineering information in ISIS and OSPF respectively. So these are two different routing protocols, and so they already had defined the traffic engineering extension, and now we're taking the same traffic engineering extension and sending it over BGP. So all of the security considerations are the sum of BGP issues and the traffic engineering in ISIS and OSPF issues. Is that a valid claim to make? Well, I said it isn't, because it's not the same. BGP is not the same as ISIS and OSPF. Why? Because ISIS and OSPF run on corporate networks. Usually, I'm sure somebody can say, oh, but I'm running BGP between my phone and my laptop. But usually, no. Usually, ISIS and OSPF run on corporate networks, and every node that participates in these protocols is owned by the same entity, while BGP runs on the internet. It's your router to somebody else's router. So it's not obvious to me that sending traffic engineering information is okay in BGP just because it's okay in OSPF. These are very different things. So again, it could be fine. Just say it. Say that these are traffic engineering, and we not and sending them over BGP to somebody else's router does not risk any attack that we're aware of. That's fine to say this, but you have to say this. Otherwise, yeah, you get the discuss. Okay, another thing we see a lot, and the first one here was actually the thing that drove people to write 3552, is we don't have to do security because security is in some other layer. This comes up as in just use IPsec. That was very common in the past. Just use TLS, that's more common lately, or just use HTTPS or IPsec with the I2NSF extension that we're doing now, and soon to be published, and just use TLS with ACME, that's been published for half a year. Okay, so each of these requires a lot of infrastructure to deploy. You can't just say, okay, use IPsec and everything is solved. If you want to tell people to use IPsec, great. Just tell them how. If you want to use TLS, that's also great. I mean, the web PKI looks trivial to use, but that's only because some companies like Google and Apple and Microsoft meet often and do a lot of heavy lifting to get it to work for you. So if you tell people to use a security layer, great, but tell them how. And this is especially relevant for authentication and credentials. Who gets credentials? How do you provide the credentials? How do you authenticate somebody coming to you to get the credential? And how do you validate the certificate? And another thing is authorization. Who is authorized to do what? The common thing we see, and everybody who has a certificate is trusted, because otherwise they wouldn't have a certificate. We wouldn't have given them a certificate if they weren't trusted. So again, trusted by whom to do what? So we have this kind of flat authorization model that anybody who has a certificate is authorized to do everything and authorized to impersonate anyone else. And no, that's not a good security model. So we see that a lot. So if you want to trust any certificate holder in the corporate LDAP environment, you say, well, we're doing this protocol for internal networks, and everybody has a certificate from the local Microsoft Active Directory. Well, every user, every employee of that organization has a certificate from that LDAP. Every machine has one. And that old printer next to the bathroom, well, that also has a certificate. And if this is a security model, then that printer can do anything within your system. That's usually not a good idea. Okay, there are more specific pitfalls for young models, and there's a link there. URIs, using them to locate resources. There's section 7 in RFC 3986. Time and replay, there's always the danger of an attacker on path, delaying packets or recording packets and retransmitting them. Broken constraints, well, attackers read the RFCs, but they're not bound by them. If we have this 2-byte field, then we have, and the RFC says the number in this 2-byte field must be lower than 500. The attacker is not bound by that. They can send a much larger number. They can send a a string as long as they want within the JSON. I mean, nobody cares, even if the RFC limits the name to just 40 characters. There's some documents, not usually in the IETF, saying, okay, this is okay for physical security because we're using Bluetooth, and Bluetooth is only works for 10 meter distance. But well, you can see demonstrations of people with a parabolic dish, and they're doing Bluetooth from a distance of a kilometer or 2 kilometers. Just use more power than the Bluetooth document says that you're allowed to. Another thing we like is cryptographic agility. I mean, if you write a document today and say, well, use ASGCM because that's the algorithm that everybody likes, but then if 4 years down the line we decide that we don't like ASGCM anymore for whatever reason, are you going to come back and write a new document obsoleting the old one? And then are you going to go and replace all the implementations that are deployed already? Probably not. So build in cryptographic agility into your document if you are doing the cryptography yourself. First, if you're relying on TLS 1.3, then good. TLS 1.3 is going to do that for you. But in that case, you want to have your implementations able to update the TLS version when necessary. This is a link, actually, if you download these slides, and there's much more there. That's a link maintained by the security ADs, and it's about the stuff they often encounter that makes them issue discusses. So read that, and you may avoid having discusses on your documents. So questions, and before I go to questions, please fill out the survey, because this is the first time we're doing this presentation, and if there's much that is wrong with it, we'd like to know so that next time we can do it better. So on to the questions.
So if there are common implementation pitfalls, I'll use a concrete example. So, for example, if your document relies on the security inherent in passing around dupes, JW keys, and you happen to know that, like, right now, 90% of the libraries out there will accept a signed JWT with the null signature. And, you know, maybe the null signature effectively renders your security model pointless. The security considerations could be a place that you could talk about that, but it's a concrete implementation detail, and if all the libraries out there fixed their implementations, then it wouldn't be an issue. Is that the sort of thing that you would want to address, or that you would want to elide, or?
Well, as a reviewer, I would never catch this missing, because I wouldn't know that all the libraries out there are support invalid signatures.
Well, they're not invalid. It's a null signature.
Okay, yeah. They're still.
They're required to accept it by a different RFC.
Okay. So yeah, but this is a good thing to call out. Yes. Okay. Of course, if someday all the libraries are better, then great. Then you'll have a no longer relevant paragraph in the security considerations. That's not a bad thing, and calling it out may lead your implementers to use a library that is better.
Cool.
I mean, advice for implementers is always in scope for any section in an RFC.
So could you comment on how you might get help? Say, for example, you're an expert on a major routing protocol in the internet, and you know that you need to do a security upgrade, but you are not security competent. What is the correct process for getting the assistance you need?
Well, the big thing is that your working group chair knows some people, knows some security people, at the very least has access to the security AD, and can get someone to review the draft, join the mailing list, look at this. We often get this request, well, this working group wants some input on so-and-so draft. Who wants to join the mailing list and look at this? And this is a common thing, and it's done. So that's the first layer. And after that, you can ask for an early sector review, and that usually gets you an answer within a month or two. And the third thing, yeah, you'll get it into the sector review, but that's kind of late. You want to do it an early sector review or get some assigned expert. And we'll do an early review for acknowledgement section.
Hi, Kirsty Payne, NCSC. Thank you for giving your presentation. I just wanted to ask, you said at the start that this was mostly about implementation and deployment considerations, yet all the attacks, or most if not all, that you listed were more...
Could you speak up? I can barely hear.
Oh, okay. Yeah, so I wanted to ask, at the start you said that this was more about implementation and deployment considerations, but then most of the attacks that you listed were communication security based. So could you clarify that sort of seeming gap to me? There's a miss on operational security or cyber defense security considerations, and just perhaps should this be called communication security considerations, or are those things in scope but you just didn't list them here?
They are all in scope, and my examples come from stuff that I know, documents that I've reviewed, and yeah. Well, this is true for IETF documents in general, and in the security area, perhaps a little more than. It's even more common that we kind of ignore operational considerations, and it happens all too often. And yeah, but if things that are important for operation and deployment, yeah, they really should go there.
And have a second question. That you mentioned it goes to sector for review. So could you just clarify, because I don't know how many people it has to go through, if there's some requirement on the diversity of technology or industry background that reviewers have to have before it can pass final?
Sure. Part of the publication process, after the working group chair clicks the submit to ISG button, is that it goes to all the directorates, and we have this list of people who are on the security directorate. The same goes for transport and routing and applications. And we have, I think, 50 members or some such. And each document gets assigned kind of round robin to a reviewer, and they write a review, and it goes in a mail to the ISG, to the IETF mailing list, and to the document authors. Maybe also to the group, to the working group. I'm not sure about that. But anyway, this goes to the document authors, and that's a review. The area directors obviously know about it. Every document has this, secondary review has this boilerplate. We have reviewed this as part of the sector efforts to review all documents. The content of this review are meant primarily as input for the security area directors. Others should treat this as any other review in IETF last call.
Hi, thank you. Back again. So you have a pool of 50 people from which one person does the review, is that right? And of that pool of 50 people, is there a conscious split of the industry sector that they're from or the background they have? Okay,
not automatically, but there is this process that when we get the list of documents that are going to be assigned, somebody can say, oh, I know about this one, and so I'd rather do my review on this one rather than whatever random document you're going to assign me. And another thing that could happen is that I get assigned something and I can't read what the terminology there, and say, I don't know anything about this. Does somebody else? We have our own mailing list, and can somebody else review this? I'll owe you one. Well, it's not privately. I mean, there's a whole script that makes sure that we don't do too many reviews. can somebody help me with this? And then if somebody volunteers, they can take the review off of my hands, and I'll get another one next round. Yes.
My name is Lawrence Lungley. I wanted to ask about side channels.
Mhm.
I didn't see any mention of side channels in 3552. The one you referenced that
5246 TLS 1.2 had a side channel, was about a timing side channel.
So you referenced that the one RFC that had the list, basically things that should go in the security considerations. And that I just looked and I didn't see any mention of side channels in there.
Well, that was one of the reasons why we wanted to revise it a few years ago. Yeah, there's a lot of things that we didn't think about in 2003 and that we do think about today. Well, privacy considerations and pervasive monitoring that we didn't think there would be any reason to consider passive attacks, because the single attacker can always mount an active attack. So why even consider passive attacks? And there's some of that in 3552. We just didn't consider at the time that somebody would have enough resources to do a passive attack on the entire internet. And now it seems that they can almost do that.
So to be a little more specific on side channels. In some side channels, like a cache timing attack, you want to be on the same sort of CPU or same device that your target attack is. Some are remote, like timing over protocols. Some require monitoring power. I mean, so I think what you're saying is probably all of them would be in scope.
Well, it depends. I mean, we are the IETF. We deal with communication security mostly, and so if something requires choosing the exact right core within the host, it's not really something that has to do with communication security. Same as that we don't usually discuss how to protect the private key within the host so it doesn't leak out. I mean, these are, we don't do everything that has to do with anything in computers. So it's a judgment call whether it is relevant for a particular protocol.
Protocol timing attack would be remote in scope. Cache timing, maybe not so much. Monitoring RF emanations with a dish from across the, that maybe.
And neither is shoulder surfing. Okay, anything else? Well, thank you, and please reply to the survey. Thanks.
Oh, by the way, I didn't catch people's name for the questions. Can you go to the Etherpad and put in your name, make it simpler?
And if somebody wants to ask whether this falls out under Notewell, I have no idea. No, definitely no Notewell slide in any of the
Security and living in different planet than people in college.
I'm not actually sure which Etherpad was. I just tried to find it. Chris Lemons.
Chris Lemon, and you're from